everyone. Hi, Pierre. So today is our first episode of the Toloka podcast. We have a fantastic guest here today. I will introduce you to him in a second. We will be talking about coding, LLM, agents, lots of cool things, evaluation, training, and other topics. Now, a few words about me. I'm Ilya Kochik. I am VP of Business Development at Toloka. At Toloka, we create human data to train and evaluate Gen AI models, work with coding, diffusers, and agents, LLMs, all of that. And let's move to our guest today. So it's Pierre Tempel. He is a product management director at GitHub. Welcome.
Thanks for having me. Hi there. I'm Pierre, or people also call me by my handle Turbo. I'm director of product at GitHub for what we're calling our detection and remediation engines. So we have this kind of sub-product at GitHub called Advanced Security, which checks for vulnerabilities and code quality issues. And we develop, normal static analysis engines like CodeQL, but also I'm in charge of our AI native engines that are used to automatically fix vulnerabilities, which we're calling Copilot Autofix, and also AI-based detections, which are powering Copilot Code Review, which you've probably seen pop up on one of your pull requests if you're on GitHub reviewing your code and giving you suggestions.
Amazing. Great having you here. So this is very exciting to finally talk to someone at GitHub. I've been following the company since like early days, and I think it's changed the way we think about software engineering. I think the Copilot is definitely making another huge leap, and it's just tremendous to see what you guys are doing. Hey, I just want to start maybe with something rather simple, right? And just ask, I know that you changed the way developers work. I know that you use Gen AI and AI and ML in the past and all other tools at your disposal. But how did it change the way you work? Like, do you use it? How often do you use it? What is the kind of workflows? Tell us about it.
Yeah, it's interesting. I mean, I was typing up notes for this podcast, and I think even just a few weeks ago, those notes would have been completely different because the landscape is just moving so quickly. I mean, the way GitHub teams are utilizing AI is very specific to their workflows. We try to supercharge every angle internally, whether that's development or product management. Like me personally, doing things like market research and competitive analysis gets a lot easier with the tools we have available now. But it also enables you to kind of free up time to do more in-depth thinking and get closer to the user. So especially when we're talking about things like benchmarking or evaluating models, one of the most useful things for me was to actually collect the data for our benchmarks and talk to our users, because you often have an idea of how your users are interacting with your product, and you have hypotheses and nice dashboards, but there's a lot of bias in those. And that bias doesn't survive actually collecting the eval data. AI can be a real reality check on that's what your users are actually doing. Those are the workflows they're performing on your platform, and that's what they actually need next. And so that product discovery aspect has been really helpful. Personally, I also maintain a platform called Findsight.ai, which is like a search engine for books, which has a few thousand users now. So that's been useful for me just to understand those systems a bit better, but also to, just discover new resources for learning. So yeah, it's been pretty transformative for me personally as well.
That's interesting. You mentioned that you use it for some of the like product research, market research, competitor research things. Like, do you find the research functionality helpful? Did you build your own workflows, or I mean, deep research functionality, or how does it look like? I'm super curious because I also tried something like that like a couple of weeks ago. It definitely speeds up. What are the
Yeah.
tips and tricks you can share?
Yeah, I think it's all very specific to your workflow. I mean, I'm on the more technical side of the product management. I mean, my background is a developer. I still write code,
Right.
for fun. And so I like building my own systems also just to understand how to effectively work with models. And so the tools we have available at GitHub and at Microsoft are, pretty open and powerful. So I can orchestrate workflows like
Wow.
Being able to keep up with the market landscape is one of the primary challenges right now. Everything is moving so fast, as I said. So you can't rely on your Gartner or Forrester analyst reports anymore, like every 2 years, because by the time you've written an answer or read an answer, it's already outdated. So having something that can autonomously work in the background, notify you of any new developments, aggregate user feedback from different channels like our own feedback discussions or Twitter or other forums has been hugely valuable. So we've got tools like Copilot Spaces, where you can create kind of your own AI workflows within GitHub, which we're heavily using internally. And watching my team or members of my team build their own workflows around Copilot is also very interesting. So we're also sharing these workflows internally.
Yeah, that's impressive. Really cool. So you mentioned that actually, yeah, I agree with you on the notion that couple of weeks, I mean, couple maybe month earlier, I would have answered those questions completely different myself as well. I like always to bring the story a little bit here from our angle, which is like the data generation and annotation. Let's say 2 years back, we will generate a data point, which is your image classification tasks on crowd workers, and it will cost $1. Then 1.5 years back, we will create a data point that will be created by, say, civil engineers in, say, Germany, and this will be used to train the model to understand questions and answer them correctly on civil engineering tasks. And this will be like a $50 task. Then 6 months earlier, or maybe 8 months earlier, we would be doing a day like generating data using medicine doctors who has 20 years of experience in the field, and they will be working for like almost a week to find the question hard enough for a frontier model to solve. And this will be like based on the amount of work they need to spend between $500 and $1,000. And today we're creating virtual companies, synthetic environments, all of that to create, like to close the gap between the enterprise data that's out there, but it's unreachable and the public benchmarks. And this will cost like thousands of dollars depending on the complexity. And all of that has happened in the span of what, 2.5 years, maybe 3 years tops. So I wonder, from your angle, what do you think is going to happen? I don't know, next 2 years sounds even a little bit too far-fetched, but like 6 months, 12 months.
Hmm. Yeah, I think what you mentioned about sort of the specific workflows around collecting data and training AI. I mean, there's obviously huge areas of machine learning that are now basically obsolete. Like if you took a look at, 1 or 2 years ago, Azure Machine Learning Services for classification, for
Yeah.
example, like hyper specialized smaller models, which are now completely replaced by more intelligent models that can transfer knowledge across domains. So I think that's going to continue. We're going to erode, part of that kind of classical ML. There's still an opportunity for obviously foundational research, but a bigger model with more capabilities is always going to win over, smaller deployments. I think there's two concrete developments that at least we're prioritizing for any of our AI workflows, which is kind of trying to make the models less dumb and more smart. So the less dumb angle is, sometimes you see just make an egregious mistake. Whether it's a function hallucination that isn't in your code base, or it, introduces a dependency in Copilot Autofix, for example, even you already have one. Things where as a user, I would look at the platform and say, well, all my code is here and all my issues are here. You should get this right. Context is really important. So taking in more of that context to make the model or the workflows less dumb is definitely a priority, but also more smart. So the original Copilot, 2 paradigm shifts ago, is just the autocomplete in your IDE. Then we had Copilot Autofix. Now we have the Copilot coding agent, which is autonomous. What they're all still are at a sort of junior level or mid-level engineer. So we want to get to a place where it's an actual senior engineer, or it's a tool that senior people can take seriously and use to supercharge their workflows. So there's a lot more knowledge that needs to be encoded, a lot more, context sensitivity. Am I working on something that's just a throwaway project, or am I working on a critical piece of infrastructure that's going to go into, aviation engineering and has needs for formal verification or something? So plugging in more of those senior level workflows is something that will make the workflows more smart. And I think lastly, we'll see a change in the workflow itself that developers go through. So right now we have, you write code, maybe with Copilot, then you have a security scan, you have testing, you've got deployment. But as models get more capable and can ingest more context and call more tools, I think we can diffuse those barriers. So you can do testing while you're writing code. You can do your UI design or give feedback on it while you're writing code. Really extend the development bubble from just writing code to creating a product or creating value for users. So those three avenues is kind of where we're targeting all of our AI features at the moment.
Very interesting. I like this. Let's dump in more smart direction. A question. So this is where I have like two hypotheses, not two hypotheses, but I think it can go either way. So the first one is, could it go into something that's more general and UI agnostic? Say agents that do lots of tasks on your behalf and you go into a completely different way of interacting. Or do you think it will go into, hey, let's have the same capabilities, but like create a very defined user journeys for each of those, right? So should it be unit test creation? Okay, there's a specific journey for this, and LLMs and all of that will help you on the way. Or should it be security testing, right? So something like this. Or so where do you think it will go? Will we ever go into like this, not AGI, but like mini AGI for coding? Just like give me a task, give me Figma, mockup, and you end up with a working code. Or you would have lots of individual journeys designed around these capabilities.
It's a good question. I think one of the most important things to keep in mind is the user problem needs to come first. So for us, it's a developer. So whatever workflow they go through, an AI system or even a non-AI system needs to adapt to it. So to your point, maybe two concrete examples. At Microsoft Build a few weeks ago, we launched two different products. One is the Copilot coding agent, which goes more into the autonomous route, where you assign it an issue and it will come back with a pull request and you can iterate on it with the coding agent. And another one was what's called an agentless system, meaning that it's still a loop that self-adjusts, but there's no planning step involved that AI does. It's user which is our validation agent for Copilot Autofix that goes in and runs your tests. It adjusts the outcome, it adjusts the fix suggestion to get it more in line with you. And both of these features are, spawned from actual user problems. Sometimes you want to just, speed up your development and assign an issue to a junior engineer. You can assign it to Copilot Coding Agent instead. You want to bulk resolve your security alerts because there's an incident like Log4j or something in the wild. You need to have the assurance that those fixes are valid and there can't be any squish in that workflow. It has to be linear. You have to see, okay, these tests were run, this adjustment was made, and full observability. So I guess the answer to your question is it's both, but it really depends on what the user problem
Right.
is. We can't just build capabilities and then throw them out into the world. We actually need to build a useful platform for our 100 million developers. And so that's where we start.
Yeah, that's interesting. Probably this is why I'll always end up in the situation where you have all these mode toggles and so on, right? Do I want to go all in with autonomy, or do I want to just, hey, just do this simple thing for me, but many times, and I'm certain about the output?
Yeah.
Awesome. So I wanted to talk to you about the evaluation of the models, but then going a little bit in the progression of complexity. First, start with what do you think about copilots in general, without necessarily going into the complexity of agents, tool calling, all of that. And then to dial it up a little bit and think about the tool calling, because it definitely creates another layer of complexities. And finally, going really cutting edge with this semi-autonomous or like fully autonomous agents. And I would start with something provocative here, right? So let's start with just copilots. Now, all three been claimed as the best competitive programmer. Now, we hear from some of our clients, enterprise clients, that still it is not performing as one would expect it to, right, in the enterprise tasks. And my question is, like, what do you think? What could be the reason? Do you see the same with your clients?
Yeah, that's a really good point. I can go a bit more into detail on the development, for example, on Copilot Autofix, which went through that same journey of, trying to meet the enterprise requirements. So we offer our security capabilities at GitHub for free to open source repos. So we have this huge, user base of open source projects, everything from, highly influential, like infrastructure command line utilities that would be on any Linux system to smaller open source projects, but also larger enterprises. And if we just look at the data between them, like how big are the repositories? How do developers actually commit code? Like how large is a pull request, for example? What languages do they use? What libraries do they use? It's
Hmm.
completely different. There's
Okay.
very, very big differences between how enterprises write code and work with their code bases and how open source developers write code. And so if we look at benchmarks out there like SweBench or others, um, first of all, they're all of pretty questionable quality. There are a few like multiple or others which try to capture more knowledge transfer than a model can do. But most benchmarks are kind of under-maintained small problem sets that are modeled on either sort of lead code scenarios or on open source scenarios, but they are not a great fit for enterprises. So when we build Copilot Autofix, for example, we can't access anyone's code. You know, we make a promise
Yep.
not to train on enterprise code, but we can see the distribution of metadata, like how big is a repo, what languages are used, etc. And also the distribution of like how often does a SQL injection get detected in an enterprise code base versus in a
Mm.
JavaScript open source repo. And so we can take that heuristic distribution and we can fit it on top of the open source data to then give us a representative set of evals that we can then
Mm.
use to say, okay, if this performs well on this distribution, then it goes to reason that it will perform better on the enterprise use case. And that's exactly what we've seen happen once we did that step, you know, and adjusted our evals and added some more expert triage as well to scale to enterprises. This is harder to do for things like open-ended coding agents, like Copilot
Hmm.
Agent, because there's not really an enterprise-grade, you know, benchmark out there. Because
Right.
enterprises, if you think about it, are extremely complex scenarios. You've got thousands of developers, you have mono repos, 100,000 millions lines of code, and you have a frequency of new pull requests, which is massive. So how do you simulate something like this? So that's where more online data, more actual human feedback from developers and watching developers work with these tools comes into play to adjust the performance. That's where the normal benchmarks are almost entirely useless. You know, we really need to get closer to the developer and watch them work with it and improve based on their feedback.
Interesting. Interesting that you mentioned the distribution or like the distribution of characteristics of the code base is different. We've been also looking into it, but like curious to compare notes here. What do you think, like in your opinion, of course, if you can share this, what are the dimensions and how they differ? Like just curious to know um, what are the key differences apart from obviously the languages, right? So no one is using Rust. I mean, on GitHub, Rust is fairly underrepresented, and there might be a couple of other languages that enterprises still use, but they're not a part of open source. But beyond languages, what else is there?
Yeah, I mean, especially for security, it would be the types of issues detected. So CodeQL can detect about 500 different types of vulnerabilities and their variants. So, um, the the types of vulnerabilities we find in open source are very different from the ones we find in enterprises. For extremely influential open source projects, for example, there's barely any detections because there's a lot of eyes on the
Yeah.
code, and no one really makes a mistake because that will end up in all the systems in the world. So, you know, there's a lot of checks in place. For enterprise code, the workflows are so different, it's hard to really capture them. One enterprise might have a massive mono repo for all of their code base. Another might have hundreds of microservices where you need to correlate findings across many, many different repositories, which we started to do as well. And even others are using GitHub in a way that's maybe a bit unexpected. So open source developers usually, you know, snap to the GitHub workflow quite quickly. You know, you open a pull request for a small feature, it's self-contained, you get reviewed, it gets committed. But enterprises might use pull requests where you edit thousands of files because they treat it as I get that code delivered from an outsourced company and I just need to merge it into code base now. And that's my workflow. And I run all of my checks at this point. So it's really very, very different. It's much more heterogeneous in enterprises than it is in open source. So trying to capture the broad middle of the distribution of characteristics is the best we can do. And then use human feedback for the extreme ends where we need to adjust things and
Yeah.
give people plenty of controls, to enable or disable AI features and other features at any given point in the workflow.
Interesting. Yeah, that makes sense. Actually, we've been also trying to figure out how to simulate this enterprise coding workflows, and we've picked up on a couple of skills differences, I don't know, dimensions. One is definitely you touched on large code bases, right? So when you think about the competitive programmer case, not necessarily about GitHub PRs, but there you would have a very self-contained but very difficult task, but it will be self-contained, right? You don't need any other files, anything. While in enterprises, I'd expect some changes in the API would go through lots of different files here and there, but the change itself, like from the mental complexity perspective, will be rather simple. So this is definitely, and I remember that when we did analysis on GitHub, you have a very limited number of PRs that touch on many files, which is the nature of the way that PRs are structured, right? So they tend to be like smaller, self-contained, and all of that. Second thing we picked up on was the migrations. Old legacy versions living together in the same repository. You need to do like the dependency bumps from time to time. You need to see what happens when there's a new version. Everyone needs to migrate to this new framework or whatever. This is also something that you rarely see, but all enterprises go through this. I think not only Go Slack, I think, was publishing something about a huge migration they went through.
Yeah.
And another one that we looked into is something that's completely not represented, I think, in the open source is take you want to build a website, internal website, external website, or an app, right? You start with some Swift or Django framework and you get going, building prototypes, like different iterations. And this is something you would never see, this kind of early stages of development, right? Of course, there's plenty of code in Django, but like no one will publish their Django website on GitHub. So this is another one where we also try to simulate it by basically just having developers, just going and crank through creating a version of, say, Wikipedia and see how it will work together with the Copilot hand in hand. So it's interesting. It's interesting that it's different. But then I wonder, you basically have some telemetry, right? You have some A/B testing, maybe. You have some feedback. But do you ever partner with your enterprise clients on just trying to create tools? It's a win-win situation, theoretically, right? When you create tools that necessarily built exactly for them, right? For their workflows on their code base. Or this is something that's still of the limits and no one still has cracked it.
Well, I think it depends on the client. I mean, definitely in the very early days, for example, for Copilot Autofix, we for a feature called security campaigns, which is a way to orchestrate a limited set of security findings from remediation with a deadline, basically, and having bulk auto fixing available. What we did before even building that was to approach some of our larger clients and build prototypes with them.
Yeah.
Just have a toy version that developers can interact with. And again, you get a lot of data from that, not just the workflow that developers are going through, but also, the quality of the alerts, the quality of the AI output, that's really valuable. And keeping this data around is actually really valuable as well, because you can then slice it in a different way later, for example, to train or adjust prompting for model calls, for tool calls, or for more context retrieval. So you can find different kinds of problems over time in the same triage data. And so, yeah, that's been pretty valuable. In general, we try to build, or we have to build tools that are nearly universal for all developers because, there's so many different kinds of developers on GitHub. We have to meet the kind of the broad middle of the population. And the specific user research is usually reserved for, some of our largest clients, and we avoid building specific solutions.
Fair enough. You don't want to overfit, basically, yeah?
Yeah, we allow customization. I mean, especially as you were saying about enterprises, you may have what we often see is proprietary internal shim libraries. So you might have a UI library that a company develops internally. You may have an ORM library that abstracts over all of the database technologies. And so we engage with our professional services teams to model these libraries in a data format that both
Mm,
our AI and Kochik can understand. So we are able to actually, analyze their code with that in mind. But again,
mm,
that's a paid engagement, and that's reserved for
sure.
when that is security critical or is a larger client.
Right. Interesting. What, now just shifting gears a little bit, maybe from your clients to your product, there's so many moving variables there, right? So you don't have your own model, you use all the models out there, right? I mean, you can use in GitHub, you can use O3, you can use O1, you can use GPT-4, you can use Claude, and so on and so forth. And it's already what, 7, 8, 9, 10? I don't remember. The number is growing.
Yeah.
On top of this, each of them have different versions. You probably have lots of master prompts that design interaction in different scenarios. Probably you have different RAG or like different ways to pull context from the code base, right? And finally, yeah, you would have a multi-step interaction between the user and the model. My question is, having probably not a very rich feedback from the users. I mean, thumbs up, thumbs down, telemetry, right? It's not exactly like a very detailed annotation. How do you optimize all of that? It's like a lot of moving parts and variables, not only from the logical perspective, how you even solve the problem, like not mathematically, but whatever. But second is like from the computational perspective. It's like
Yeah.
probably quite expensive to run those.
Yeah, I think there's two unique benefits of being, within the Microsoft ecosystem and the GitHub ecosystem, which is one, we have very, very flexible, scalable infrastructure. So if you look, for example, at what we call our responsible use documentation, which goes into detail for each of our AI features on how it's built, how it's being tested, and sort of what evaluations we run regularly, you'll see that we're running, for example, Autofix evaluation against thousands of real-world code bases every single night. And it takes just, a few hours just because we can scale our
Right.
infrastructure up and down that quickly. So from an infrastructure perspective, we're not really constrained in that regard. The other benefit that we have, and that's something AI native companies are going to struggle with very soon or are already struggling with, is expertise. So, for example, if you have a company out there that does AI-based security or quality reviews right now, you might start out with experts in Gen AI. You can do your prompt engineering, you can do your last mile fine tuning or adapter tuning, but you hit this limit where you need expertise in programming languages, in language analysis, in formal verification. And since we've been building these products for a few years, we have those experts. And they, in turn, can encode that knowledge into automated systems that allow us to scale our evaluations. So, for example, when you say you interact with a model on GitHub, what you're actually interacting with is a massive cascade of models. You have your foundation model, you've got your harmful content filter, you've got your duplicated code filter for like copyright detection, you've got other filters, security filters, etc. And the training and adaptation of these filters is something where we can apply this expertise. So when we do red team testing, for example, we can seed our evaluation with that expert curated data and then use AI to scale the test volume massively. So we cover the depth with the expertise and we cover the breadth of testing by scaling this testing data set with AI.
That's really interesting. So basically, you are saying that this is eventually the same hybrid Copilot approach, but on the red teaming side, right? When you started just humans doing the doing, and then you scale it, and you help them to be 10x more productive, because you use again models to do the red teaming for you and cover not necessarily the edge cases, but to make sure that the average, if you wish, is good enough, and you get the scale at the good cost point. It's very interesting. Yeah, this is something that I've heard that many in the industry attempt to do. I think there's reasonable questioning on how accurate is it, right? So using synthetic data just without necessarily human being in the loop sometimes might lead to very poor diversity, but the combination probably will solve the problem, wouldn't it?
Yeah, it's the combination. And it's also then grounding every step in human feedback. So We can
Mm,
again take a representative slice through the data. We've done this with Autofix, where we've got 300 real-world vulnerabilities per
mm,
language ecosystem that are actually triaged by multiple experts. There's one expert that is a security expert, and one expert
mm,
is an expert in that programming language. So they will
mm-hmm.
rate the results, categorize them, give some rationale. And we do this with multiple people, so we can do a confusion matrix across all people and spot disagreements. So that's a way to cover blind spots. It's the same as like unit test generation. You wouldn't rely
Right.
on an AI to do unit tests alone. You can use it for the volume of tests, and the more it gets, and then you can do things like multi-model invocation voting mechanisms to, any statistical tool to increase your confidence. But you have to ground it in human expertise or formal verification at some point. And that's, we've got 60 plus engineers just in my group who are experts in program analysis. So that really helps in kind of seeding this data for example, Autofix.
Interesting. What do you think? Do you think agents are coming there anytime soon? Because agents effectively can do the reinforcement learning within the closed loop where you have an environment that gives you back the feedback, the signal. Also, they can do a little bit of the research in the like on the open web to find different vectors of attack or anything like this. So, do you think at any point you will be able to completely switch over to agents who will constantly just, eat in the compute resources to find those new vectors, explore them, and do reteaming on their own? Or do you think humans will be still there for years and years to come?
Well, I think the majority of testing or scaling can be done by AI, whether it's an agent or someone invoking the agent. But especially the initial planning steps and kind of the optimization that really goes in depth,
Mm,
that's something where you need to apply expertise at least once. And this pays off over and over again in dividends. So, for example, when we built the initial version of Autofix, we, had the human triage, and then based on that, we made decisions on the accuracy, and we published that data. Now we're in a world where developers are interacting with it and they're having success, but there are things like that we notice where it's dumb or not smart enough, like it's missing context, for example, from the rest of the code base. Then we can go back to the same triage data and say, is there a subset of this triage data where we have context hard problems? So if the model had access to more context, would it have improved the rating of this triage outcome? Then we can create a subset of that as an eval. We can use that to adjust our prompts and tune models to improve them. So I think you can't remove the humans from the loop because you need that sort of gold nugget at the center of your triaging or of your workflows. But of course, the more you can scale the workflow, the faster going to be able to execute on it. I think we're still very, very early days in terms of tuning. We
mm.
are in our classical RFT and SFT tuning paradigms. I think a week ago, a new tuning paradigm was released called Cure, which evolves a coding agent together with the ability to generate unit tests. And that's already a massive improvement in accuracy, where the first response from the model is much more likely to pass unit tests and formal verification. So I think there's loads of gains to be had still in evolving models with tighter real-time feedback before we need to think about making the entire workflow agentic.
Right. What if we dial up the complexity here up a notch? So we mentioned a couple of times tool calling and other external capabilities. Now, again, having this evaluation question in mind, I wonder, so say today, Copilot can, I think, do plenty of tasks on the repository, read files, execute some things, can go and check something online. It could go and check something on GitHub, which
Yeah.
basically creates a lot of other external dependencies that are not only like have latency, but also they evolve in time, right? So the evaluation today will be different from the evaluation tomorrow because the rest of the world is changing a little bit. So how do you solve it? Do you have this problem in the products that they're working on?
Yeah, I think sort of tool calling, a central frustration with the current kind of energy around tool calling for me as a product manager is tools are a how. not a why. Like in the essence, you still need to address the user problem. So if you have an
Right.
MCP server somewhere, you have the ability to call a particular tool. That doesn't magically solve a problem. So you need to start with evaluation first. So as I said before in my example, if we think we can improve the accuracy of autofixes or findings from Copilot code review by showing it additional code, then we can create evaluation set, and then we can think about, okay, what kinds of tool calls would be impactful to resolve this knowledge gap. It doesn't help for it to just be able to execute random command line arguments because it'll likely end up in a dead end where it can't dig itself out again, and that's the worst case scenario. And once you go through that exercise of actually creating the evaluation, what you often notice is that you don't actually need a full agent where the planning is left to the AI because you've basically already modeled the user workflow. So you can actually kind of put that into a fixed loop and use AI and tools in a deterministic manner, and that's much easier to evaluate. Free roaming agents are hard to evaluate, and that's where we're working with our research teams and the industry to improve the benchmarks as well to model these kind of more complex workflows more accurately. But I think that's always just the frontier. As soon as you spot something that becomes a workflow, it's much better to model it in an agentless way because it becomes predictable and users can rely on it, and then you can scale it. Like if you're confident that the validation agent for autofixes does the same thing every time, then you can just apply it to the next 100 alerts rather than the next one alert. But if you just assign an issue to Copilot and it goes off on its own, you might get a slightly different answer every time. So that's a good first step. That's a good sort of junior development type workflow. But for real, like scalable enterprise workflows, I think you need to lock parts of this system in over time based on your evaluation data.
That's a very that's a very insightful thought, actually. Now, basically, what you're saying is you find the repeatable workflows that agent would have came up with. And what you do then, you can hard code them effectively, right? In the UI, or how does it look like, by the way? Is it that you still hard code them within an agent? So the agent knows, okay, I'm in workflow one, I'll just follow the steps prescribed to me, or do you completely rip apart and just create a good old software engineering rule-based workflow on the back of it?
I think it depends on the workflow. So, for example, for the validation agent, it's very simple. Users report that they want Copilot to run their tests and see if they pass. They want Copilot to rerun CodeQL. So we can give it a limited set of tools, and then depending on the integration surface, we can decide which tools it's allowed to run. But you can do this in a much more subtle way, for example, through DPO, direct preference optimization tuning, where you watch the workflow that a user goes through and you can say, okay, this is a productive direction, this is an unproductive direction, unproductive direction. And you can nudge the model over time towards more
Right,
realistic scenarios. So, that's a sliding scale, but both
right.
are valid approaches.
Interesting. One of the ways we've seen, and we work more on this open-ended workflows, because this is like more LLM-based, LLM-grounded scenarios. One of the ways we try to do this is we just try to basically mock everything up, right? So there will be mocked up MCP servers for, say, your SAP, Salesforce, GitHub, Slack, whatever, you name it. And there will be like a lightweight API front end and some lightweight base like SQLite or something on the back end that just simulates one part of the behavior. And then you can run it at scale. You can even use it for reinforcement learning if you wish, because you have the final reward that's coming back, right? So what the sequence of tool calling calls, successful or correct
Yeah.
or not. So did you use this, by the way, for any of the external systems that you simulate, or?
Yeah, I mean, we try to use synthetic data where possible, or as I said, scale our evaluation workflows with AI-generated data or mocks. But to be honest, GitHub is an enormous platform. So in things, for
Right.
example, in our security products, there's plenty of data out there. Actually, the data cleanup is probably the hardest part.
Right.
Disentangle the workflows that developers actually go through. But yeah, if we can avoid going only on synthetic data,
Right.
that's good because it's really easy to fall into this kind of comfort zone and bias of, okay, I'm only going to encode this test that I think we're going to see in the wild, but getting to real world use cases as soon as possible, and even maybe working with customers to get real world data and then anonymizing it to a point where we can use it as a test case is a valid approach.
Fair enough. Yeah, this is actually one of the avenues that we are now also trying to explore is like creating three bench equivalents, but for enterprises or specific enterprises based on their specific code base, and then like funneling these insights to fine-tune the model to perform without necessarily exposing any of the code back to the
Yeah.
model. So this is definitely a golden standard, I would say. Hopefully, it will become a golden standard when you use the actual data to improve your products and models.
I
I
think that's
wonder,
going to become something very, very important is this workflow modeling and workflow discovery.
right?
It's something that we currently leave to ourselves or other companies creating AI tools, but what we need is a sort of meta AI that goes in and, watches how users are actually interacting with the product and platform and can give you proactive insights into the workflows that they're doing to encode them. The
Mm,
context is important, but this falls under the topic of memory. If you have an autofix or a suggestion from Copilot, it shouldn't make the same mistake twice, ever. It should remember what good looks like for your workflow. And that applies to end-to-end agent workflows as well.
yeah, this will be very interesting to unlock, and even more interesting to unlock in such a way that some anonymized insights could be shared in between instances. Because definitely there's only some of the knowledge is
Yeah.
specific to one company, but there's plenty of high level knowledge that like that engineers would take with them once they go from one place to another, and they will spread this like best practices or some of the uh, guiding principles for the architecture or for the code maintenance and so on. So hopefully one point LLMs could also exchange this sanitized version of knowledge. Wonder. So on this question of designing these workflows versus having a more like universal approach. Now, do you think how scalable do you think it is? Right. So something it reminds me a little bit of the situation that AI has been in 80s, right? So when people thought that hey, I will just codify everything in a rule-based system, take all the experts in the world, they will just define the rule-based system of the rule-based knowledge, and then you go ahead, this is your AI. Now, could it be that now we're in a situation where, as opposed to just designing the system, we design all the sort of workflows and all sorts of evaluations, benchmarks, and so on. But again, we will end up with humans having to design evaluation or workflow for every single situation out there.
I think we saw one of the downsides of using sort of automated evaluation only in the recent weeks. I won't name any names, but there were sort of several model releases, including open source models, which launched at allegedly the top of the leaderboard for things like Sweetbench and others. And you look at them and go, well, these models are tiny. How could that possibly be happening? How could they be, completing these complex agentic workflows? And it's that they're overfitted to the benchmark. They're overfitted to tool calling. I think right now the industry is moving in a slightly unproductive direction where we're having too much emphasis on the kind of MCP buzz and tool calling buzz, and all the benchmarks are going to be designed around this. And that's a reinforcement loop. Because if you use one of these models and you try to apply it to something that's outside of its comfort zone, whether it's a different language or a different framework, something that requires general knowledge to transfer between domains, they fall apart. You get this model collapse. So if you look at something like O3, for example, it's amazing. Like I have chats with O3 that are so large they crash the OpenAI interface because there's so much context in it, and yet it still responds without hallucinations and accurately. So it has the ability to transfer that knowledge. So we somehow have to come up with either a benchmark that captures this quality, and there are a few that are kind of developing at the moment, but none are really ready for prime time. Or we have to ground the training and evaluation of these models in human feedback still, which is why I don't think experts are going to go away anytime soon, whether it's the experts in any particular domain building the models, nor expert developers like senior plus staff developers that are actually working with these models, because you'll always need that, grounding, those boundaries where you need that human expertise still.
Right. Yeah, definitely there's plenty of opportunity, not opportunity, but incentive to overfit on the public benchmarks. And someone once said that, first researchers would start with the most general approach ever, but then once they see the performance of the model, the product, or the method, whatever, on the public benchmark, they have this incentive to add a little bit of, tweaks here and there, a little bit of rules and like an extra logic that actually effectively they codify their own knowledge, but only related to a specific benchmark that's making the system less general. And by improving performance on this benchmark, they just significantly lose on the like universal applicability. Right. What if we dial up the complexity even further and discuss agents a little bit? So you mentioned that there's two paths they will leave, probably like two different scenarios that will leave simultaneously, right? One is the very more predictable but more narrow workflows, and the second is like more open-ended and more agentic, and where you don't necessarily where you like leave just the question open-ended. So from your perspective, like today and like in 3 months, in 6 months, where the developers would benefit from these agentic cases?
I think if we watch developers interact with the tools right now, or even just in public feedback forums, it's still a bit colored by the previous way AI and even Copilot worked, where you have your development and then the sort of Copilot is sort of added to it as a feature. You go to it, maybe you ask it something, or you go to it in agent mode and you ask it to do something and it comes back later. What I think the future is, and acquisitions like OpenAI acquiring Windsurf, for example, are no coincidence. I think where we're going to see an integration of the entire workflow. Like the AI, the agent is always active, is always going to be up to date on your code base, on your architecture, on previous things that has successfully achieved within your enterprise, so that at every step of the development, there's this effortless collaboration between you and the agent, rather than you telling it very specifically what you want and it goes off and comes back. Because honestly, someone getting a business idea or something is never going to be able to articulate requirements accurately enough to say, go build me a SaaS product that's going to make me 5 million ARR in 1 year, with a nice UI. It's always going to take a developer, but the developer and agent are just going to grow much, much closer together. And that's why our tools are changing. And that's why GitHub as a platform is changing the way developers interact with it. That's why we're changing VS Code to interact in a more agentic way. I think that's where the future is going.
Right. So basically, what you're saying is that as opposed to me having a conversation each time as if you're the person or like the model, like I met it first time, you would rather retain this entire history, all the successes and failures, experiments and conversations, back and forth questions, editations, and so on, just to make the future conversation within the project or like within the repository or whatever it is within the session more productive.
Yeah, I think development isn't about writing literal characters of code into
Yeah.
an editor, right? It's all about information sharing. It's kind of Conway's law. Like, how do you break down the barriers between all the systems in an enterprise that need to give you the context as a human and give you the knowledge and insight to be productive? So what I think this is going to majorly affect is developer fungibility. You may have previously spent 10 years honing your skills in .NET, ASP.NET development, but now you can be effective in web development for any language or framework, especially also proprietary frameworks used in an enterprise, because the agent is already active within your enterprise and it has that knowledge and can help you just immediately do stuff. We never want to end up with users in a dead end where they have to take a step back and go, what's the next step? What do I need to do now? What's the next planning thing I need to do? Like, either there's a button they can click to just do the next step, or an agent is already giving them the information proactively on what they need to do next.
Interesting. Just this weekend, literally, I wanted to experiment and to somehow make Claude Code to summarize all the conversations we used to have and just store them somewhere. Because like in the future, it will be helpful. I was like experimenting with mocking up different alternative prototypes. And even though like 9 out of 10 ended up to be a dead end, like this knowledge alone might have been better helpful in the future. And also the another dimension that you mentioned here is indeed there's lots of knowledge within the organization that gets lost once people move, and not to mention that new people join in all the time, gets a lot of time to get up to speed, to find who is the right person to ask the questions and so on, while the code base is there and the agent could just persist this knowledge and explain in the layman's terms, basically. This is fascinating. Yeah, actually, I've never thought about this as a like likely direction. I wonder now, having touched on this long independent chains of agent performing different tasks, I looked into the consumption in terms of tokens. And how do you guys feel about this? It's just like it's in a lot. And I'm not sure that I've seen a lot of information about trying to optimize it, but it's just like burning down tokens at a huge pace. Do you do any kind of optimizations to make the chains or like this trajectories more straight?
Yeah, for sure. I mean, we try to optimize both the amount of context we give it as well as the amount of calls to an LLM that we do. Because ultimately, I know we need to pay for those model calls as well, which is, internally we
Yeah,
are much more efficient at sharing those resources. But, O3 is still 5 to 10 times more expensive to run, whether you're Microsoft or you're a customer.
yeah,
So you might end up with a premium request versus a normal request. So we try to optimize this. And I think this is becoming an industry thing. If you look at, for example, I mentioned the Cure paper earlier.
yeah,
One of the metrics that's starting to be introduced in these research papers is token efficiency.
right.
Is how does this new approach help reduce the amount of tokens it takes to get to a correct response? And there's loads of other technologies, like, for example, gisting, where you use special vocabulary tokens to encode entire
Yeah,
workflows into one. So there's loads of things you can do. In general, I think we're still going to move in a direction where we need more context in the model. And as always, and this is a personal prediction, I have no inside information on this as far as Microsoft goes, but I think physical architecture is going to win. So companies like Grok with a Q or Cerebras who are building like parallel physical architectures for inferencing engines, something like that is going to come and disrupt this industry, just like ASICs disrupted Bitcoin, going away from GPUs. What's missing for success there, I think, is um, someone coming in and actually integrating libraries into the tools that we're using to build these models. QDAR dominates for a reason because it's massive, it's everywhere, it's used by every developer. So that's what I think is holding that industry back. But if you look at some of the announcements that Microsoft has put out or Google around their TPUs or others, I think efficient inference from a hardware perspective is going to move faster than we can save tokens with more efficient prompting
right.
on the kind of product side.
Right. Interesting. Yeah, basically the same has happened with just regular CPUs and whatnot, right? The progress was much faster than optimization of code. No one is doing this famous Quake 2 square root optimizations any longer.
Yeah.
Um, hey, just want to ask a final question, just a bit of forward looking. Now, do you think will it happen? Will it not happen? If we end the yes, where we will completely forgo all the like coding language and all of that, and completely move into the abstract words and like natural language as we talk to between you and I now to create software or even to create yeah, new interfaces, new products, and all of that.
Yeah, I think so. I think if I had to sort of summarize it, I would say that development, and not just encompassing writing code, but actually thinking about architecture, kind of implementing designs and everything else, is going to move to a much more outcome-driven um, mode of operating, where right now you have these trenches of expertise around particular frameworks or languages or others. But if you have a model that can translate across languages effortlessly, then you are getting rid of a huge amount of risk that is currently facing companies of, entrenching themselves into one particular framework and then, it becomes legacy. Now we need to move to something else. You can accelerate that move and you can always keep up with the times. and you can deliver value immediately. Like if you have an agent that helps you implement a feature in a day versus a week, even if that feature might be using a different library than you're familiar with or a different language, then that is the value you're creating for your business. And I think that's where the commercial kind of value is unlocked in agent-based development. But we also have to be sort of careful with this, right? I mean, it's a double-edged sword. What about things like security and assurance? Would I want to fly in a plane where most of the code is AI contributed? I think formal verification and grounding in tools is going to become a massive industry. Right now people are paying for cybersecurity insurance against, normal vulnerabilities. But what about AI caused, incidents or vulnerabilities? So at least my team, I think I'm very excited about our direction in, grounding AI and securing AI workflows well into the future. But yeah, impact and outcome driven development is where agents are going to have most of the impact, I think.
Amazing. So then you'll keep us safe in the future to make sure whatever's been made up with LLMs will not fall apart. Awesome. Thank you. This was a very insightful conversation, Pierre. Thank you for coming. Yeah, so everyone, it's been Pierre Tempel from GitHub, Director of Product Management. And you have here myself, Ilya Kochik, VP of Business Development at Toloka. Thank you for listening in. Have a good rest of the day. Bye-bye.